Let's look at an SN2 reaction between bromomethane and a hydroxide anion. We first start by drawing the carbon-oxygen bond which is going to be formed, and now we're going to be setting the parameters of the different bond lengths during the SN2 reaction. Firstly, we'll be changing the bond lengths of the carbon-oxygen bond, followed by the carbon-bromide bond through the SN2 reaction. We are now going to run the simulation of finding the transition state. It's going to be in a solvent of water, and this is going to be a one-coordinate reaction. We can see that on the left, this is going to be the reaction coordinate, and the x-axis is going to be the CO bond distance that is forming. The y-axis is going to be the energy of this transition state, and by looking at the maximum, we can see what the transition state will look like. Performing a 2D simulation where both bond lengths are considered will give us a more accurate picture, and looking at the saddle point, this will be where the transition state is.
One of the functions of SciGress is providing the IR and NMR spectrum of compounds. After we have drawn a molecule, we can run an experiment to generate the IR spectrum. Once the calculations are complete, we go to Analyze to view the IR spectrum. We can click on the individual peaks to observe which peak corresponds to which vibrational mode. Using the same molecule, we run another experiment, this time for NMR. Once the calculations are complete, we can view the NMR spectrum under the Analyze tab and identify which peak corresponds to which atom.
One of the features of SciGress is its ability to generate CSF files, a SciGress readable file type, from PDB files or This is an example of a biomolecule generated from a PDB file. We are able to view its properties from Analyze, Model Properties table, and here we can see that it is a hydrolase 1C25 enzyme. We can also view some of the characteristics of this enzyme. When we select atoms, we are able to view the X, Y, and Z coordinates of each individual atom. When we select bonds, we are able to see the bond connectivity between atoms and the type of bonds between each atom.